I just wanted to talk about the exam a little bit on Monday. So only three of you actually ended up taking the exam because the rest of the students did not finish their homework assignment. Um, some actually didn't even get started. And if that is something that's going to continue, then you're causing trouble for yourself. Um, because that affects your overall grade. So when your homework is incomplete, or you don't get started, you don't work on the quiz, which means you cannot get to the exam, that's a lot of grades that are being affected, right? Your homework grade, quiz grade, exam grade, everything is being affected. Now at the end of the semester, I will drop your lowest chapter exam score. So if you have one missed exam, that can get dropped and it will not affect your overall grade. But if you have incomplete homeworks and you have more than one missed exam, it's going to be hard to recover from that. Some of you are not turning in those other homework assignments that we have, the logic puzzle, the sets assignment you did for chapter 2, with the RH testing, the blood group example that we had. And all of those count as homework grades. So if you're missing out on so many assignments, your overall grade is going to get affected. And you know you can only recover so much. You won't be able to recover from everything, even though at the end of the semester I will give you guys a chance to go back and work on any incomplete homework and quizzes. I do not let you go back and work on exams. There's no makeup for exams because I let you drop your lowest chapter exam score. There's no makeup exam. And if you think, if you have 2 weeks or more where you can work on homework and you're not using that time, that last week of the semester, when I give you a chance to go back and incomplete any missed assignments, is not going to be enough. That's just a last minute chance of, trying to bring up your grade. If you had like 80-90% on an homework, trying to get it up to 100% so you can get more points. That's kind of the idea with that end of semester, giving you a chance to go back and finish anything that might be incomplete. But if you have 2 or 3 chapters worth of homework to finish, you're not going to have enough time. And that's the reality of things. So you really want to think about, why am I taking this class? What's the purpose of this class? Do I need this for another program? And if I need it for another program, then I really need to get serious about this class. If this was a class you took because you needed it as a filler, then maybe it's time to think about withdrawing from the class. Because if you are taking some other classes that need your time and your attention more, then staying in this class, you're just using up your time ineffectively, because obviously you're not doing the homework assignments and stuff for this class. So it may be better to think about, what, can I withdraw from this class and maybe spend more time concentrating on my other classes where I still have a chance to pass and do well on my grades and that kind of thing. So evaluate yourself, because only you can do that. I cannot help you with that. But evaluate yourself and see, if I'm staying in this class, I need to put the effort in. And if I cannot put the effort in, I'm going to end up failing this course. And I don't want to see you guys do that. I don't want to see you fail. So either you change your strategy, which obviously has not been working for you, because if you've missed 1 exam or 2 exams, if you didn't even get started on homework, or did only one section of homework and didn't even get to the others, then you either need to change your strategy, or like I said, think about, do I really need to stay in this class? And I know it sounds really harsh, guys, but we are getting, we're almost at the halfway point of this semester. And if you're not seeing a good passing grade in the class, it's not going to change drastically in the second half of the semester. So please be very, very mindful of what you are doing and why you are doing it. And then decide how you want to be with this class. Because, that's just how these classes work. You have to put in the work, you have to put in the time if we're going to see any form of success. So that's all I wanted to let you guys know. I was very disappointed to see that majority of the class did not take the exam. Like I said, we had only 3 students So more students did not take the exam than the number of students who did. And that should not be the case for any class. So just please be mindful about that. And I really want to see you guys succeed. If you're struggling on homework, waiting till the day of the exam or the day before the exam to ask me for help is, obviously not a good strategy. So think about today, you need to get started on chapter 4 homework. Even if it is due sometime next week, next Wednesday, next Friday, you have enough time to ask for help from me, from the tutors on campus. So get started today, because please keep in mind, I do not check my emails over the weekend. And if you're going to wait till the day of the exam to ask me for help, there's just not enough time for me to get in touch with you and offer you that help. So that last minute thing just cannot happen, especially when you have 2 or 3 sections worth of homework to finish. So like I said, change your strategy if you want to successfully complete this class and move on with a passing grade. All right, guys, that's all I wanted to tell you about that. Let's get into our chapter 4. So like I said, this is going to be on statistics. So we'll get into some different calculations, some different forms when we are talking about statistics. And, as you can see, they're starting out with the first statement saying statistics are everywhere. I mean, if you think about it, we have statistics, of course, used in education because we look at success rates, we look at passing rates, how many students are taking classes on campus this semester. So, statistics can be in so many forms. Of course, we just had the census completed last year. So you will see all this data coming from the Census Bureau, which is all going to be on statistics, right? Because they gather information from people, newspapers, magazines, television. I mean, everybody, if you look at different articles and stuff, are throwing, statistics or some numbers at you. We're talking about radio, but even think about something like commercials, sports is a big place where you will see statistics being used, right? Like they're talking about the team statistics. They can be talking about an individual player and how the player has performed with the team or during the season, or just however they want to break it down. So statistics is something is used a lot in our everyday life. So it really comes down to being able to distinguish when good information is being thrown at you and when maybe information to maybe mislead the consumer is being thrown at us. So, being able to decide if it's really good information or, it's just being used to influence the person in one direction or the other. So when we talk about statistics, we'll look at many different things about it. Now, we're not going to get too in depth like a statistics class. So think of this as more of just a basic 101 introduction to concepts of statistics. So we're talking about the field of statistics can be defined as the science of collecting, organizing, summarizing data in such a way that valid conclusions and meaningful predictions can be drawn from them. And think about it, that's what the Census Bureau is doing. It's trying to make good, valid conclusions, and then based on that, make predictions. So if you guys follow state news at all, then they're in the process of redistricting the congressional districts of Colorado, because with the census, they realize that we have seen so much growth in Colorado over the past 10 years, from the last time they did the census, that we now have enough people to actually have an 8th congressional district in Colorado. So, for the past several weeks, this independent organization has been trying to redistrict Colorado, trying to see where they can fit in that 8th district. So, they've been sending out maps to the public and people have been commenting on it and stuff like that. And they finally made it to the Supreme Court of Colorado to see, if it gets approved or not. So that came from the Census Bureau, the data they collected in Colorado. And based on that, they were able to say, what, we have enough to have a whole new district in Colorado. So just an example of how statistics kind of comes into play. Now we can actually break down statistics into 2 different parts. So we have the descriptive statistics, which comes from that collecting, organizing, and summarizing of data. And then the second part is the inferential statistics, which is where we're talking about, drawing those valid conclusions and making meaningful predictions. So just breaking it up into two parts: the collecting, organizing, summarizing descriptive statistics, and then drawing conclusions and making predictions will be the inferential statistics. So some terminology to understand as we're going through this chapter is, what do we define as a population and what do we define as a sample? So, they're using the example of, who will become the next president of the United States. So they're saying, political analysts spend a lot of time and money trying to determine what percentage of the vote each candidate will receive. And they are saying, because there are 175 million registered voters, so if that is what you think of as the population of all the people who are eligible to vote and, they're registered to vote, they are saying basically it would be, obviously impossible to get in touch with each and every one of them and ask them, who do you plan to vote for? So in this case, instead of going to all of those 175 million people to get that information, we would take a sample of those people. So we would just take a smaller group of people and ask them, who they were intending to vote for. And then the idea is, if that was done properly, that data was collected in a non-biased, proper statistical process, we could expand it out to the entire 175 million registered voters, and we can say, this is kind of where the voters are leaning towards. So the idea is, everybody who is registered to vote becomes the population, and then the group that the people want to study, the political analysts, that smaller group is what we would call as the sample. And so in this case, you can see they are saying the set of all objects under the study is called the population, and any subset of the population is called a sample. So you can see we're again going back to set theory, what we talked about in chapter 2. So your population, so in this case, think of those registered voters in United States. They become your universal set, so they become our population. And then the subset we take from them to actually, perform the study becomes our sample. So again, you can see we're using a Venn diagram over here to kind of help us visualize the difference between population and sample. So that would be some terminology to understand. So here we're just basically saying, when we are studying a large population, we might not be able to collect data from every member of the population. So we collect the data from a smaller, more manageable sample. And once we have collected the data, then, we can summarize our results, by doing different calculations. So you can find what the average is. We can find maybe what the variance and standard deviation is. So that would be part of the descriptive statistics. And then we can, based on, the information we have, we can then draw our conclusions and see, okay, so which candidate were people, leaning more towards, who they were going to vote for. So all of those would be, part of the inferential statistics, making those predictions of, who's going to win the election and that kind of thing. So they're talking about. So this was just an example over here of, just a poll they conducted, and it was the Harris poll. So they're saying, what event of the past 50 years do you most wish to have witnessed firsthand? So, what were the top 5 responses from this Harris poll was, Neil Armstrong walking on the moon, the fall of the Berlin Wall, I Have a Dream speech from Dr. Martin Luther King Jr., inauguration of Barack Obama, and apparently the wedding of Prince Charles and Princess Diana. So again, you can see, if they were going to do this poll, they're obviously not going to go to every single person And they don't really tell us if they did this poll in the USA or if they just did it in general, with just anybody living in the current time. But you can see kind of what the 5 most answered responses were. So just an example of again how you are collecting your data and the information you gather from the data. So one of the big parts of our sample would be, of course, collecting the data. So first you would have to define your sample. You would have to say, okay, if I am, interested in how many people like to go hiking. So first you would have to identify who your population is going to be. And then the idea is, can you get in touch with everybody who hikes? Or again, would you try to find a more smaller, more manageable group of people that we could, ask the question to? So the idea is, once you have collected your data, you need to organize it, right? You have to organize it. And then after organizing, we have to summarize it. So one of the more common methods that we use is what we call as the frequency distribution. And this is a table. So this is what we use as part of, collection and organizing of the data. So we are saying each element in a set of data is called a data point. So again, just some terminology over here. When the data are first collected, the data points might show no apparent patterns or trends. And so we have to get into, summarizing the data and then detecting if we can find any trends. So you need to start by organizing data. And the most common way to organize data is frequency distribution. And if you think about the term frequency, we're basically saying the number of times, something occurs. And in this case would be, whatever your data point is, how many times does it occur? You can also, based on the frequencies, calculate our relative frequency, which you can think of relative frequency as converting a frequency into a percent, as a decimal. So basically you can see we're saying the relative frequency of a data point is the frequency expressed as a percentage of the total number of data points you have. So if you think of it as a percent, but again, we normally leave it in the decimal form. So what I wanted to do was just kind of walk you through this example, but I have an example for us to work on for this. So this one is saying, while bargaining for the new contract, the employees of To Die for Clothing asked their employer to provide daycare services as an employee benefit. So examining the personnel files, the company's 50 employees, the management recorded the number of children under 6 years of age that each employee was caring for. So how many kids did the employees have who were under the age of 6 years? And so they have the data here for their 50 employees. So you can see this is the raw data that they got from looking at the personnel files. So now this is the collection of the data part, but now how do you organize it? And this is where this idea of a frequency distribution table comes into play. So the first thing you have to do is identify your smallest data value, which as you can see would be 0, and then identify your largest data value, which seems to be 5 over here. Yeah, I'm not seeing a 6 in there. Yeah, and as you can see, 5 was our largest number. So we go ahead and list all the different numbers we have. So the employees have anywhere from no kids who are under the age of 6 years old to a maximum of 5 kids who are under 6 years of age. So you can see you can have 1 kid, 2 kids, 3 kids, 4 kids, or 5 kids. Then they are doing a tally to see how many employees have how many kids. So you can see they had 16 employees who had no kids under 6 years of age, 18 employees who have 1 child, 9 employees with 2 kids, 4 employees with 3 kids, 2 employees with 4 kids, and just 1 employee who has 5 kids under the age of 6 years. So when you add that up, you can see that adds up to our 50 employees as we expected. And then to calculate our relative frequency, they are taking 16 dividing it by the total number of employees, or the, the total of your frequency column. So that's 16 divided by 50, which gives you your fraction and your decimal. Now they're showing you here as a percent, but like I said, normally we just leave them as decimals. So when you add up your decimals in relative frequency, they should add up to 1, or, of course, if they're doing it as a percentage, it should add up to 100. But your relative frequency column, if you're leaving it in decimals, then it has to add up to a total of 1. And now you can kind of see, this shows you, at least in a much better format than just looking at the raw data, that, how many kids do people have, and is there a need for the company to offer daycare services at their, at the company for these employees, so these kids have somewhere to go. And, of course, it makes it easier for the parents. So organizing it in a table, helps you see the data a little bit more. And then later on, we will get into how to graphically display your data. And that's where you can use histograms to then display what you have in your frequency distribution table. So you can kind of then graphically look at them and see, okay, so what does my data tell me? So this was a basic example for what a frequency distribution looks like. We can actually also have grouped data. So in the employees daycare example, you only had numbers going from 0 to 5. So it was easy for us to just create a category, just for 0, 1, 2, 3, 4, and 5. But, sometimes your data is not going to be that simple. So if you look at this example over here, this is talking about Keith Reed is an instructor for an acting class offered through a local arts academy. The class is open to anyone who is at least 16 years of age, and they are telling us there are 42 people enrolled in this class, and their ages are listed over here. Now, if you try to create a table like this one over here, you can imagine how long that table is going to be, because you would have to list, every single age that is listed over here. There may not be as many repeating numbers as we saw in the daycare example. So in examples like this, we actually create classes instead of having single numbers. And by classes, I mean, you kind of have, the first class is going from age 16 to age 24, and that's not including 24. The second class is going from age 24 to age 32, and again, not including 32. So you will see we're including the lower limit, but we're not including the upper limit. So we're basically saying this group will go from ages 16 to basically less than 24. So you can think, 23 or maybe 23 point something, because you're not including 24 in that calculation or in that category over here. Then the next one begins at 24, but it's going to 32. You're not including 32 again. So you can almost say, 24 to 31. Then you pick up at 32 in the next class, and you go to 39, because again, we're not including 40 here. 40 is included in the next class. So going from 40 to 47, 48 to 55, and then 56 to, I guess, 63. And it's interesting that your textbook does it in this form. If you were to look at a statistics textbook, they would actually do it in this format, because you never want to have overlap between your classes. So it's not like I can say 16 to 24 ages going here, but then put the 24 here again and say, 32, because now if you have 24 over here and 24 over here, well, where does that person go who is right at 24 years of age? Do we put that person in the first category or in the second one? So that's the reason why we don't like having overlaps in these classes. And that's why most statistics textbooks, follow this format of 16 to 23, then pick up from the next number, 24 to 31. What your textbook is doing is it's using this less than, equal to, and less than symbol. So it's showing you that 16 is less than or equal to, which means 16 is included, but then it's only using less than 24 here, which means the 24 is not included in the first class, the 24 is included in the second class. So they're just using inequality symbols to kind of show you, how they're keeping those overlaps from not happening. But the idea here is we are using these classes instead of single numbers. So everybody who falls in the age of 16 to 23, goes into that first class. So here are some calculations based on how we come up with these classes. So you have to start by finding your largest and smallest data values. So you can see that's going to be 16 and 62. You can see there's the person who was aged at 16 years old. Here's the person at 62. So the first thing we do is find our largest and smallest values, and then we find the range. And the range is a calculation where you subtract the smallest value from the largest one. So we're basically saying our data values go from anywhere from 16 to 62. That's a difference of 46 years. Your range is a calculation of dispersion, and we'll be talking about that either in 4.2 or 4.3, one of those sections there. So to create our classes, we do have to start by calculating the range. After you have calculated the range, then you have to create between, and they are talking about it is customary to create between 4 and 8 groups of data points. So that means how many of these classes do you want to have? So they're saying it can be anywhere between 4 and 8. If your data is really large, sometimes it can go up to 20 classes. But looks like right now we're just keeping it within that 4 to 8 different classes. So what they're saying here for our example, we're going to go ahead and choose 6. So they want to choose 6 classes to have in this distribution table. So the next thing we have to do is actually calculate the width of each class. So we have to know how many numbers are going to go into each class. So that's what we call as class width. So this is where we take the range that we just calculated over here, 62 minus 16, which gave us 46. You take your 46 and divide by how many classes you want to have. And since they said, we're just randomly choosing 6 classes, you divide by 6. 46 divided by 6 gives us 7.66666. Now, this is something we need to remember over here, guys. No matter what your decimal number is, you always round up. So always, because even if this had been like 7.11111, we would have still gone up to 8. Because if you round down, then you're actually going to leave some of your data values out. So you always round up. So like I said, even if this guy came out to be 7.11111, we would have still rounded up to 8. So always round up when you're calculating your class width. And then we can start calculating our classes. So you start with your lowest data value, which is 16. You add 8 to it, which is this class width we just calculated. So 16 plus 8 gives us 24, which actually is the beginning of the next class. And then usually, like I said, you stop at the number before that. So you do 16 plus 8, which gives us 24. So that means 24 is going to be starting my next class, which means my first class has to end at 23. Now, if I add 8 again to 24, that would be 6 plus 2, so 32, which means this category has to stop at 31. If I add 8 again to 32, 32 plus 8 would put it as 40. So this should stop at 39. So you keep going, basically till you have your 6 classes. So this guy would stop at 47, 48, what would that be? 56 for our next one, which means this guy would stop at 55. Now to calculate this number over here, we would actually have to do 56 plus 8 one more time, even though we have our 6 classes over here. But to calculate this number, I still need to know what the next class would begin at. So 56 plus 8 would put us at what, 64, which means this guy here should stop at 63. So we don't really need the 64 for our classes. We just needed it to calculate what this upper limit on our last class will be. And if you see, that's pretty much what we had over here as a class breakdown. So just a different way of writing our classes, but now we know all the ages that are from 16 to 23 will go into the first class. So then you go back to your raw data over here and you start putting people in which age group they fall into. So if you start with 26, well, 26 is going to go into the second class. So that would be, the first tally mark over here. And then you have, okay, 48 was my next age. So 48 will go into the fifth class. So that would be, this mark over here for 48. So that's kind of how you use your tally then. Our next one is 29. So 29 will be in the second group. So again, that would be your next tally over here. So that's kind of how then you use those tally marks to help you come up with the frequency for each of the age classes we have. Your frequency column should again add up to how many people were taking this acting class. And that was 42. They did tell us that. Yeah, so they told us there were 42 people who were enrolled. So you can see our frequency column adds up to those same 42 people and then calculate your relative frequency. So 11 divided by 42, 13 divided by 42, 7 divided by 42. And again, they're using percents, but remember, again, mostly we just leave them as decimals. And again, your total should come out to be a total of 1, or as a percent would be 100%. So they're giving you just the basic steps over here on how to calculate a frequency distribution. So that's what we're going to do over here. And for this one, I actually picked a data set that I have over here for US candy production. Let me actually share this link with you so you guys can work along with this if you like. Oh, okay, let me change that to this. Okay, so if you have your ames.edu account, you should be able to get it. And, of course, all of you do. So I'm sending the link for this document through our chat on Zoom. So you guys should be able to click on that link. And it will bring you to this page. So what I have here is just, it shows you as a, industrial production as a percentage, how much candy was being produced in a given month in the United States. So it actually goes from January of 1972 all the way to, I think, 2007, no, sorry, beyond that, to August of 2017. So all the way from January 1972 to August of 2017. So just to keep our data a little bit on the lower end, because, we just want to practice with this, how about, since 2017 is not complete, we'll start at December of 2016 and go up to January of 2015. So that'll give us, 2 years worth of data. So I'm actually just going to copy January 2015 to December 2016, and you will see there's actually a second page on the worksheet which says template. I'm just going to go over to the template side. I'm actually just going to paste the data I calculated, so that way, I'm only working on the data for those 2 years. So again, you will see I picked data from January of 2015 to December of 2016. So just, 24 data values over here. So the first thing we actually want to do is find out, what our smallest data value is going to be. And, the reason why I'm using Excel or Google Sheets here is so, we can do some of this um, without having to spend a lot of time, searching for stuff. Google Sheets is a little bit of a funny document. Excel is a little bit better, but because I wanted all of you to be able to come in here. What I'm going to do is I'm actually going to just copy that industrial production. So you know how much production they had in those months. And I'm actually going to sort my column to go from A to Z. So it actually puts it in order from smallest to largest number for us. And you can see that makes it easier for us to find out what the smallest data value and the largest data value can be. So, just using technology to make it simpler for us. So you can see the lowest data value in this case is 97, and then the highest data value, let's see what that number at the bottom of the list is. You can see the highest is 127. So just by doing it this way, we can find out what the smallest and the largest data values are. So 97 and 127. I'll actually go back to our template page over here and put that in here. So 97 and 127. So it helps us calculate the lowest and the highest data values. If you guys are familiar with Excel or Google Sheets, you also have the max and the minimum functions that you can use to find the highest and the lowest data values. If that is something you're familiar with, you can definitely use those functions as well. So that's the first part in creating your frequency distribution table, is starting out by finding your lowest and your largest data values. Then remember, we find the range of these numbers where you subtract the lowest data value from your largest one. So can you tell me, when we subtract these two numbers, what do we get as the range for these data values here? So from 97 to 127.
You get 30.
Sorry?
30.
30? Alrighty, very good. So again, just subtract the larger from the smaller from the larger, and you get your range. So we've got our range now. Now we have to decide. Remember, your textbook says to choose between 4 to 8 classes. And so we have to decide, how many classes you want. And this is the part where you can play around with and see how many classes do you need. So do we need to have just 4 classes? Is that enough? Do we need to have, anywhere like 5, 6, 7, or 8? So you can start by saying, okay, maybe I just want to start with 4 classes and see what my, set will look like, what my distribution will look like. So remember again, guys, for your class width, you have to divide your range by the number of classes to get your class width. So again, if we just use the built-in calculator here, we can take 30 divided by 4. And you can see it's coming out to be 7.5, which means when we round it up, the rounded up answer should be 8. If you want to change that to, let's say, 5 classes, then, of course, you will need to change your width and divide it by 5. So you can see when you divide it by 5, your class width comes out to be 6. Nice even number, so you don't have to round it up. So just, how many ever classes you want. So remember, this part is based on you, the person who's, coming up with the frequency distribution. And for now, let's leave it at 5 classes with a width of 6. Now, how do you come up with your class limits over here? So start out with your lowest data value. And since our lowest data value is 97, that can actually be our first class limit, the lower end of our class limit. And then remember, to calculate our other classes, you have to use the class width for that. So then for the next one, you are going to take 97, which is, the class limit for the first class and add your class width to it. So add 6 to that, which will tell you where your next class will begin. So 97 added with 6, which is your class width, gives us 103, which means the upper limit on that first class has to stop right before 103. So that would be at 102. And the way your textbook is doing, and if that's kind of how your homework in WebAssign does, so that means in WebAssign, this would look more like 97 is less than equal to X is less than 103 for that first class limit, which means then your next one would start at 103, but this is of course where we would be including it. And then we would have to find out, what the other limits are. In a table like this on Excel or Google Sheets, of course, we're not using the less than equal to notation. So that's why we're going from 103 as the beginning of the next class, which means the previous class would have to end at 102. So it's just a notation thing between the way your textbook does it and how you would do it on, Google Sheet. So since we are creating 5 classes, guys, we will have to keep doing this for, 3 more places. So now you started at 103 for the next one, which means for the third category, we would have to go from 103, add that class width of 6 again, which puts us at 109, which means this second one will end at 108. For the fourth class, we would take 109 and add our class width of 6 again, which of course puts us at 115, which means for the third class, it would end at 114. For our fifth one, again, same thing, we would take 115 and add 6 to it, which would give us 121. So obviously the fourth class will end at 120. And we've got, 4 of our classes taken care of. We just have to finish this fifth one. So remember, to be able to calculate that upper limit, we need to know where the sixth class, if we were going to have a sixth one, where it would begin at. So same thing here. Let's just do 121 plus 6, which gives us 127, which means this guy here would end at 126. And so we have our 5 classes. We don't really need that 127. We can go ahead and get rid of him. And you can see you've got your 5 classes over here. So questions on the process so far of coming up with our lowest and highest data values, the range, the number of classes, the class width, and then based on that, the class limits for our frequency distribution.
I just have a question. Isn't our highest data value 127?
Yeah,
So wouldn't we need another category in order to fit it in, or no?
yeah, I'm glad you mentioned that. So that was my next question is, we decided with 5 classes, and just as Nicholas pointed out, you can see our 127 is not even included in that final category. And that is something, and I don't know if your handout mentions that or not, that is something you have to be careful about as you are designing these classes. So you can see when we stick with those 5 classes, the highest data value is getting left out, which means we need to change the number of our classes. Our classes are not enough. So this is where I would probably increase this guy by 6. And that means my class width is going to change, because remember, that's range divided by the number of classes. So that would be 30 divided by 6. So now you will see it makes our class width a little bit narrower. It's going to be only a class width of 5, which means all of these values here are going to change, because now you will be adding 97 with 5, because your class width is now just 5. And we would be creating Sandra, if you can, I would prefer for you to stay till the end, but if you need to leave, that's fine. Okay, guys, so we will of course then need to go back and recalculate. So you start still with the lowest data value of 97, but now we're only adding 5 to each of these categories. So I'm actually going to go ahead and do that part first. Let's go ahead and create all of these lower limits. So keep adding 5 to the previous class. So that would be 107 plus 5. And of course, you can use the built-in, yeah, Cynthia. So when you change how many classes, you are going to have your class width will change. So yeah, definitely keep that in mind as you're going through your example. So let's see, we've got 4 classes so far. Now we have 112. Oops. 112 plus 5. 117 plus 5. And that's 1, 2, 3, 4, 5, 6. And I actually need a 7th class so that we can have that endpoint for the 6th one. So, okay. So now since my second class starts at 102, this one will of course end at 101. My third class starts at 107, so this guy will end at 106. 112 for the next one, so this guy will be 111. 117 for the next one, so this guy is 116. 122, so of course this guy ends at 121. And then 127, which is still really bringing us to 126 only. Why is that happening? But 127 as my highest data value. 97 as the lowest one. So yeah, when you subtract the 2, you get 30. This was 1, 2, 3, 4, 5, 6, and we still have 127 left out. Yeah, I'm actually going to make this smaller and see if that helps us out. So divide this by 4, which means we will have to round up to 8 for our class width. Because increasing it did not change. Okay, so 97 plus 8 will give us 105. And I'm actually going to let Google Sheets do the calculation for us. So I'm just using the cells where I have these numbers typed to do the math for me. So I'm taking, you can see the cell where I type 97, adding it with the cell where I have my 8 as the class width. And then we're going to do this. And I think this will work. So you've got 105, which means this guy has to end at 104. 113, so this guy would end at 112. 121, so this guy ends at 120. And since this is 129, this guy ends at 128. And you can see this actually works out well because now my 127 has a place to go. So increasing the class numbers was not helping us. So we went in the other direction and we decreased it. So now you can see everybody has a place to go in. And then this is where you can do your tally. So you can see our first number of 110 is going to go into the second one. And you can do this by hand if you wanted to, or you can keep doing, 1 plus 1 plus 1 for each time you run into one of your, values. So like 110, we know goes over here. 109 will also be part of that same one. So I'm just going to add, 1 plus 1 in that space. So that adds up to 2. So you can use that also, to do your little tally marks. 107 also goes under that same class. So that's adding another 1 to that space. So you can see, you can kind of go through all of these. Okay, 101 will go under the first class. 97 obviously is part of that also, so you can go ahead and add your 1. So you can see that's probably, and depending on how many, oh, not what I wanted to do, depending on how many data sets you have, that can take a little bit of time to kind of get through those calculations done. But again, we're not doing this with very big, long, large data sets. We're going to keep it, probably with what you're seeing with the examples and stuff. So hopefully it's not going to take you a whole lot of time to get through that. So same thing, our 6th value over here is 101, which will again go into that first class over here. 103 will be part of that same first class, so add another 1 at the end. You know what, let's make these guys bold so we know we've used them. You've got 116, and there's actually 2 of them, so that will go into our 3rd class over here. So 1 plus 1 for those 2 numbers. Let's see, 127, 125, these will go into our 4th class. So that would be 1 plus 1 for those 2 numbers. You've got 120, which will go into the 3rd category. So plus 1 for that guy. 109, 108, 108. So that's 3 of those numbers in the 2nd category. So I'm actually just going to add 3 for those 3 numbers. 104, 102, 102, 103. So that's 4 numbers over here, part of the 1st class. So add 4. Okay, getting down to the bottom, let's see, 105, 109 should be under the same class. So that's 2 more numbers under the 2nd category. And then let's see, what do we have? 119, 116, 117. So they will all go into the 3rd category. So 1, 2, 3 in the 3rd category. Now, the only way you can know that you did these calculations correctly would be to add your frequency column. So add all of these numbers in your frequency, and I'm just using the built-in sum function and selecting those 4 cells. And when I add them up, it gives me 24. And I have 2 years worth of data here for each month. So yeah, that's going to be, 12 months times 2, 24. And we've got 24 data values. So that tells you, hopefully we put all of them in the right place. So that's how you calculate your frequency, improvise your little tally marks. Or like I said, you can do the tally on paper and then just put your total in the frequency column. Now, when it comes to relative frequency, remember, this is where you take the frequency for that class and divide it by the total number of data values. So that means we will be taking 8 for that first class and dividing it by 24, which is the total data value. And again, I'm just letting the built-in functions do the calculation for us. But for each one of these, it's going to be 8 divided by 24, 8 divided by 24, 6 divided by 24, and then 2 divided by 24. And that gives you your relative frequency. And you can increase or decrease the number of decimal as you want. And then again, remember, this should add up to a total of 1 when you leave it in decimal form. That's 100% as a percentage. So really, that's what's involved in creating a frequency distribution table, is doing your class limits, especially if you're going to be doing a grouped frequency data, is coming up with your class limits, based on this little calculation over here that we did with the range, number of classes, and the class width. And then once you have that to help you design the class limits, then all you have to do is, tally your frequency, add it all up together, and then calculate the relative frequency. And you've got, the steps listed over here. You, of course, got a couple examples to look through. So that's basically what's involved in creating a frequency distribution table. And then, like I said, after you do the frequency distribution table, then we also like to get into graphs to kind of help visualize that. So before we get into the histogram part, any questions on the table formation over here? So again, remember, your lowest and your highest data values have to be included within your frequency distribution, and that comes from the number of your classes. So you will have to play around with, especially if the problem doesn't tell you how many classes to use. If they leave it up to you, then that's where you kind of have to play around and see, what the appropriate number of classes would be. Now, as far as histogram goes, basically you can think of them as being bar charts because, they do have those bars as part of them. And histograms are definitely used, for your grouped data set. So we use, you can use histograms for that first example we saw, with how many kids the employees had for the daycare. You can do that, but, histograms are definitely used a lot with the grouped data sets. So in this case, they're talking about to construct a histogram, mark off your class limits on the horizontal axis. If each interval has equal width, they're saying, draw two vertical axes. The axis on the left can exhibit the frequency. The axis on the right can be for the relative frequency. So, the decimal or the percentage part of it. A lot of times you will only see one horizontal and one vertical axis. So not everybody does the two axes, for frequency and relative frequency, but obviously you can. And then they're talking about, draw a rectangle for each interval. And then the height of the rectangle basically corresponds to that frequency or to the number of data points which were in that interval. And, the different heights will tell us which group had the maximum points, data points as part of it. So in our example over here, you can see obviously our first two classes had the highest frequency because each one of those have 8 as the frequency. So that's telling us there are 8 months out of these 2 years where the candy production was between 97 to 104% and 105 to 112%. You can see the candy production, only 6 months had a production of 113 to 120, and only 2 months where the production was even higher, from 121 to 122. So the frequency just tells you, in our example, what months had, that level of production. In this Reed's example, you can see we were talking about the age group of the people who are taking the classes. So there are 13 people who fall into the age group of 24 but less than 32 years of age, or 24 to 31 years of age. The next highest category would be people even younger than that, from ages of 16 to 23. You only have 2 people between the ages of 48 to 55. So the frequency just tells you, how many people fall in that age group, in that age category. And then when we convert that to a histogram, you can see on the horizontal axis is the age in years. And this is literally going from your class widths. So you can see we go from 16 to 24, which was our first class width, 24 to 32 for the second one, 32 to 40 for the third one, so on and so forth, till you get to that last age of, didn't mean to do that. The last age where we stopped at, 64 years of age, anybody younger than 64. So that's exactly what's reflected over here in your histogram. On the left-hand side, they're using the frequency. On the right-hand side, they're using the relative frequency. And you can see, again, we're leaving that in decimals. And then, your frequency, of course, is in whole numbers. So for 16 to 24, we had 11 people in that age group. So you can see it kind of corresponds to right there at 11. In the second age group, 24 to 32, we had 13 people in there. So you can see this corresponds to about 13. 48 to 56, we only had 2 people. So you can see it's kind of corresponding with that height of 2 people. And then on the right-hand side, you have the relative frequency. So you can see again, for the first group, it was 26%. Second group was 31%. So this would correspond to approximately, 0.26 over here and 0.31 over here. So that's kind of how they're using the left and right, vertical axis. But like I said, a lot of times you just have one vertical axis. You don't normally end up putting both of them on the same histogram, but you can. So that's kind of what, this is talking about. And here they're actually talking about, what happens if your intervals were not equal in width. So you can kind of see if you change those class width. So they're going from 15 to 20, obviously not including 20, 20 to 25, 25 to 30, 30 to 45. So you can see they are all technically they're 4 units away, but you can say it's a class width of 5 for these first 4 classes. But look what happens on that last one. You went from 45, instead of going from 45 to 50, you're going directly from 45 to 65. That is a big, wide class width, and see what happens to your histogram. Actually, that's the same thing that happened on this one also. Instead of going from 30 to 35, you're going from 30 to 45. So that's a class width of 15. This is a class width of 20. This was a class width of 5, 5, 5. So look at how narrow those first 3 columns are, and then look how wide these last 2 are going to be. And so obviously, as you can see, they're talking about why this can be misleading, because we are going to be tempted to think this is their biggest group, because look how big that rectangle is. And we would not even think about, these guys as having any significant values in them, because what's happening over here is we're not concentrating so much on the height of the bar, right? We're looking more at the total area of the bar. So we're looking at the height, but also in how thick the bars are. And, of course, these 2 are going to stand out more. And these guys kind of look, skinny, so we may not even think about it. But if you look at those frequencies, look how close these frequencies are to each other. So they're nearly the same height, but, obviously this guy looks a much bigger category just because how thick it is. And this is, some of those things that we have to be careful about. And that's the reason why we insist that, our class width has to stay the same for all the classes. So we don't really want to end up, with bigger classes just because it suits our purpose. So something, we kind of have to be careful about as we work through this example. So here they get into a little bit of discussion about relative frequency density to kind of avoid, some of these situations over here. They're talking about, rather than comparing the heights, the eyes are naturally comparing the area of the rectangle. So they're saying, therefore, to make an accurate comparison, the areas of the rectangle must correspond to the relative frequency. And this is what we call as the relative frequency density. And you can kind of see the formula over here. So they just kind of walk you through the calculations. They're talking about, you take your relative frequency, which was, the frequency for that class, divided by the total number of people, and then dividing it by your class width. So, first find your relative frequency and then divide it by your class width. and then use those values to draw your histogram. And when you do it that way, you will see now your area corresponds to the height of the category, the interval you were looking at. And in this case, you can see, since we are using the relative frequency density, these two bars don't have almost the same height as the second one, like this graph did over here. So you can see now their heights are not the same, but this is a more accurate representation if you wanted to keep this class widths over here. But you know, now the height will correspond with the area that it should be. So you can see for each of these calculations, you found your relative frequency, so 4 out of 42, but then you had a class width of 5. So that's where our frequency density calculation is coming in. For this fourth category, we found our relative frequency, 11 out of 42, but then our class width was 15. So you divide that by 15 and you can see what that area comes out to be. For the last class, we had 10 out of 42 for the relative frequency, a class width of 20. So then your density will have that calculation. And then based on that, we can calculate our histogram. But again, guys, this is not a very traditional way that you will see histograms either. You know, some people might use this because they want to show the area with the, you know, the height of the histogram, but this is going to be a more common way that you will see histograms being presented is, you know, keeping the class interval the same for all the classes and then just using frequency or relative frequency on the vertical axis to show the heights of our histogram. But, you know, just again, something to be aware of if you see something different in, like I said, statistics is everywhere. So if you see something that looks different, then you can at least kind of make a sense of, does this even seem like a legitimate graph or information that's being shared? This other example here, again, is just talking about how you can, yeah, we're almost done, Cynthia. How you can create a histogram based on relative frequencies for group data. So it's kind of walking you through that example over here. So I definitely ask you guys to look through this. So what we will do next time is actually try to create a histogram based on this example that we did over here. Google Sheets has a little bit of restriction on how the graphs will look, but, you know, we'll still be able to create a decent graph, you know, more like a bar graph, but we will still get an idea. And then we'll look at just this last part of section 4.1. So we'll finish that part with our discussion with the histograms, and then we'll get into section 4.2, which is where we actually start talking about averages and how to calculate averages with, you know, these data sets. So again, part of that collecting and organizing data that we're looking at. So any questions right now, guys? No? Okay, so this is where we are heading forward with chapter 4. So again, please get started on the first part of chapter 4.1 homework, okay? All right, everyone, have a wonderful day, and I will see you on Friday morning. Be careful, everyone. Take care. Bye, guys.
I had a question.